Good night. Yeah.
Hey.
Why?
Start this.
Oh,
Doesn't really. First person in here. Just get a flash camera. The what? You got problems.
Sorry. Well, you're on camera, so I can't.
Oh, green water. No, Braden had a bottle. Braden. You go fill it up? Probably. Braden.
Oh, orange.
No, I turned it in. I didn't even feel it. Yeah, it was sticky on my computer. I would, yeah.
Yeah.
Here,
Hot door. Okay, actually, on the left.
only if they're, this is the last place they were going to food, so it doesn't do much.
You watched the next podcast?
Good afternoon, everyone.
Good night.
Ready? Okay, so before we get started, I want to remind you that when I ask questions, I want you to raise your hand if I don't specifically call on you. Okay? Yes? Yes? So yesterday was the English 2-star test, and Miss Carter was over helping with the test. So that's why we didn't have it in class yesterday. Are you ready to begin? Yes? Okay. Yes, Kason?
Yes.
Alright. Thank you. Okay, so Wednesday we went over factoring, right? So what's the first thing we have to look for when we factor? Yes, Karen?
Greatest common factor.
Greatest common factor. After the greatest common factor, we have to look at the number of terms. If we have 2 terms, what are the 3 things that we're looking for? It's on the flow chart. Yes, Gracie?
Difference of cubes.
So difference
Squares.
Difference of squares. What else?
Sum of cubes and difference of cubes.
So yes, Gracie said difference of squares, sum of cubes, difference of cubes. Does anyone remember why we can't have a sum of squares? Yes, Braden.
Because it has to be plus or minus.
Yeah, so it has to be the plus and minus. So we have that plus and minus together makes our last number that minus. So there's nothing that we can have that plus or minus that will give us a positive number in there, right? So now we're going to multiply and divide rational expressions. Does anyone remember what the word rational means? Yes, Braden? Okay. Angel, do you remember what rational means? No?
Oh, yeah, I do.
Kason?
It has an ending decimal or something like that. Like it ends, it doesn't go on forever.
Yeah, okay, so that's one way of putting it is we have decimals that ends, it terminates, right? So if it never ends, then it's irrational. What else does irrational mean? Brayden, did you raise your hand? No? The word I'm looking for is in the word rational. Ratio, very good, Gracie. So ratio, also known as fractions, right? So does anyone remember how we multiply fractions? Yes, Brayden? Yeah, keep, change, flip. Well, that's not, is that multiplying or dividing?
Wait, no.
Multiplying fractions, yes, Gracie? Across what?
Multiply the numerators and multiply the denominators.
Very good. So we have to multiply our numerators and then multiply our denominators. Very good. So before we look at number one, what we have to do before we can multiply or divide is the first thing is we have to factor our numerator. And then we also have to factor our denominator. Once we factor both of those, we have to go through and simplify. When we simplify, we're going to cross out anything that we have in common between the two, right? Simplify. Okay, so let's look at number one. We've got 8x cubed minus 2x squared over 4x squared minus x. So the first thing is we have to factor the numerator. So when we factor, what is the first thing we look for? Yes, Brandon? Greatest common factor. So, Topher, what's our greatest common factor of 8x cubed minus 2x squared? 2x squared, very good. And then when we factor that out, Topher, what's inside the parentheses?
4x minus nothing, or just 4x minus 1.
Alright, so Topher said that it was just supposed to be 4x. Why do we have to have the minus 1 in here, though?
Keep that negative.
Yeah, Braden, raise your hand.
Because 2 over 2 is 1.
Yeah, so 2 over 2 is 1, so anything divided by itself is 1. So here we had a 2x squared, but this is also our GCS. So when we factor this out, we're dividing the 2. So anything divided by itself is 1. If we don't have this 1 here, and we multiply this back in, remember, that would not equal up what we originally had, right? Yeah? Alright. Angel, what's our GCF of the denominator? It is x. Very good. So when we factor the x out, what are we left inside the parentheses? Yes, Braden?
4x minus
4x minus 1. Very good. So are both the numerator and the denominator completely factored now?
1. Yes.
Yes. So after they're completely factored, we're going to go through and cancel out anything that both the numerator and the denominator have in common. This is because, just like we said when we factored out the 2x squared from 2x squared, we divided that by itself, it was 1. So it's similar here because if we divide something by itself, it's 1 again, right? Yeah? So we're going to cross out here 4x minus 1 on both because 4x minus 1 divided by itself is 1. It just cancels out. Then we have 2x squared over x. Can that be simplified? You said yes, Brandon? How can it be simplified? You said 2x? Yeah? So we'll have 2x here. Why is it 2x?
Because, don't you like look at the exponents, and then it's technically a 2 and 1.
Very good, Brandon. So he says that we have to look at our exponents here. And if you look, we've got a squared here, and then we have no exponent here, which means we have a 1. Right? Yeah, so when we divide, so remember from laws of exponents, when we divide like bases, we subtract the exponent. So we would have 2 minus 1, which is 1. So this leaves us with 2x as our final answer. Are there any questions on this one? No? Alright. So, number 2, what do we notice about the numerator? Yes, Brandon?
You have to factor them
We have to factor our group, and why is this?
in. There's more than 2 terms.
Yes, well, more than 2 or more than 3? More than 3, right? So we said on our factoring flow chart that we have on there that if we have 4 terms, so 2 terms we have to look for sum and differences, right? 3 terms was when we use the swing method or just the sum and product with factoring. And then 4 is when we use grouping, right? So when we factor by grouping, we're going to first group off the 2x cubed minus 6x squared, and then we're going to group off 7x minus 21. Is everyone following so far? So, Annabelle, what is our GCF of 2x cubed minus 6x squared? 2 2x squared, right? So we'll factor out a 2x squared. When we factor that out, Thomas, what are we left with inside the parentheses? Close. So 6 divided by minus 3. There we go. There we go. So yeah, we factored the 2x squared out, so our x's cancel out, our x squares cancel out here, and then we have 6 divided by 2, right? Yeah? What did I say we do with our sign in the middle here?
Go to the middle.
Thank you, Ethan. We bring it down, keep it in the middle. So it was already said out though. Okay. Bryce, what's our GCF of 7x minus 21? 3? Wait, does 7 and 20? Does 7x and 21 have a 3 in common? No, what do they have in common? What does 7 and 21 have in common? Well, is 21 divisible by? Is there anything you can multiply to 7 to get 21? What? Yeah. 7, right? So they both have 7 in common, right? So we would have a 7 as our GCF down here. So when we factor 7 out, what is up inside the parentheses? Yes, Ethan? X minus 3, very good. So what did I say about these two sets of parentheses here? Yes, Taryn?
They're supposed to be identical.
They're supposed to be identical. Very good, Taryn. So since they're identical, we can go ahead and bring down an x minus 3 for both of them. This is because we're factoring the x minus 3 out from both of these sets of terms here, right? So what's left for the second binomial then? Yes, Brayden? No, we already brought down x. What? Well, no, we already brought down x minus 3. What's left up here? Taryn?
Put the coefficients together. The 2x squared plus 7.
Yeah, so he says 2x squared plus 7. Very good. So yeah, so we take our x minus 3 out of this one, we're left with 2x squared. So 2x squared, and then from this one we pull x minus 3 out, we're left with a positive 7. Yes?
Why can we pull out x minus 3? The first one, just the one under this.
This one? So if you look at these, it's like we have, this is one whole set of terms, and then this is a whole nother one, and we're adding them, right? So if you look at these, they both have an x minus 3 in common. So we can factor that out, which then leaves us here with the 2x squared, and then plus 7. Does that make sense? You seeing that now? Good. Yes, Brayden?
Are we still doing the numerator?
Yes.
I thought we did it.
No, we're still in the numerator. We're still in the numerator. We have to factor it. So is x minus 3 completely factored?
Yes.
2x squared plus 7.
Yes.
Yes. Why can't we factor 2x squared plus 7? Yeah, well we can't factor sum of squares, but is 7 a square?
Yes.
No. Is 2 a squared?
Yes.
No. No, right? So this one we have nothing in common here to begin with. So our numerator is then going to be x minus 3 times 2x squared plus 7. Now we have to factor our denominator. So Addie, how do we factor our denominator? X minus 3, x plus 3. X minus 3 times x plus 3. Very good. And why is this? Because then when you boil it, it cancels out in the middle, so it's left with negative. Very good. So with a difference of squares, we have to have that positive and negative in there because it's supposed to cancel out our middle terms. Very good. So, Shyla, is there anything up on here we can cancel out now that we factored both of them?
X minus 3.
We can cancel out our x minus 3's. Very good. So this leaves us with 2x squared plus 7 over x plus 3. Can we simplify the 2x squared and the x in this case?
No.
Yes.
Why not, Jabez? You're the one who said no, why can't we? What?
I didn't say anything.
You don't tell her.
Okay, Brayden.
They don't have the same coefficient. No.
Wait,
Does it have to do with the coefficient?
Like we did on this problem.
Yes, Taryn?
Because they have different exponents.
No, wait, because they have
Okay, but if you look above, we had the different exponents and we simplified it. Okay, whose hand did I see next? Kason.
It's because of 7 and 3.
Yes, very good. So it's because of the 7 and the 3. It's because of the 7 and the 3. Wait. Okay,
You can't do anything with those.
He was
so you
raising
can't
his
do
hand.
anything with these.
so if you look here, we canceled out our x minus 3's, right?
Yeah.
Because they were completely identical. Your binomials would have to be completely identical to be able to cancel. So here we've got 2x squared plus 7. Because this plus here, we have two terms, so we can't just cancel the 2x squared and the x. These have to be completely identical. Does that make sense? Yes, Kason?
What if it was like 2x squared plus 9? Could you divide the 9 by 3 and then subtract the.
No.
You're saying
So-
what?
Yeah, they have to be completely identical. If there was something that, so if we had something up here to where we could factor out and then get an x plus 3, then yes, we could cancel it. But in this case, there's nothing here that we can pull out to make this look like this. Does that make sense?
So that could only factor, no, that could only simplify if there was also an x plus 3 in parentheses.
Yes.
So even if there's like, you said if we could factor out a 2, if we could do that,
Yes.
then
So
we would be able to do that. 'cause
yes,
it'd be
so okay, let's look at this. Let's look at something here. If we had 2x plus 6, is there anything we can factor out of that?
2.
Yeah, we can factor 2 out, which would then give us what? 2 times what?
X plus 3.
X plus 3. Well, then we would have an x plus 3 over an x plus 3. Does that make sense? In this case, there's nothing we can factor out of 2x squared plus 7 to make it look like x plus 3. Does that make sense?
So you can't just like straight up divide it.
Yeah, we can't just straight up divide it. If you wanted to plug, if you wanted to pick an x value in and then try to put it in each of these, then it's going to come out looking a bit different. You could use different x values to test this out. So our final answer here is 2x squared plus 7 over x plus 3. Are there any more questions on that one? No? Alright, what do we notice different about number 3?
It's
multiplying.
multiplying.
We're multiplying. Very good to the two who said that. So, what did we say at the very beginning about multiplying fractions? Yes, Ethan?
Multiply the numerators by the denominator.
By the
That's
denominator?
what she said. Oh wait, no. And then multiply the denominator.
Yeah, very good. So we multiply across the numerators, then we multiply across the denominators, right? Before we can even look at doing that, we still have to factor each part of this.
Fantastic.
So, does anyone want to walk me through factoring our first numerator here? Why do you say we can't do it, Jabez?
I didn't say that.
Brayden?
I already did it.
Yeah, it's
Some
x minus 3x plus 3. Or wait,
No, it's
Talking
2x
about?
yeah, it's
minus 1 parentheses x plus 1.
x minus 3x plus 2.
And you have to do the 2x.
it's
Alright,
2x.
How do we factor a trinomial?
Sum and product.
Thank you, Casey. So we'll have our sum and product. So what's our sum?
1.
Negative
No,
1.
it's 2.
Negative 1. Thank you. So
Negative 6.
our sum is the coefficient of the middle term here.
Yeah, I know, but the 2 on the. You silly numbers.
The 2, so that's where our product, it comes in with our product.
Oh.
So what's our product then?
Negative 6.
Negative 6. How do you get there, Annabelle?
Multiply 2.
Yeah, we have to, because our coefficient here is not 1, we have to multiply this to our constant at the back. Please focus.
My bad.
Thank you. So we had to multiply the 2 to the negative 3, which gives us negative 6. So what factors of negative 6 will add to give us negative 1? Yes, Taryn?
Negative 3 plus 2.
So x minus 3 and x plus 2 is what Taryn says. So, very good. Are we done factoring here yet? No. What do we have to do before we can finish factoring? Yes?
Swing.
Swing. Very good, Brayden. So, how do we do the swing method on here? Yes, Brayden?
It's 2x minus 3 and then x plus 1.
How'd you get to 2x minus 3?
Divide them both by 2.
What?
Divide them both by 2.
Yes, so we divide both these by 2. Very good. We see here that the 3 over 2 is simplified so we can swing the 2 to the front. So we're left with 2x minus 3. And then the 2 over 2 simplifies to 1, so we'll have x plus 1. Now is that completely simplified and
Yes.
factored?
We're done.
Yes. Well, we're done with the first numerator. Alright. Yes, Brandon? Do you have a question?
Wait, I have a question.
Yes, Gracie?
Could you go ahead and multiply and then factor?
So, we could, but that's going to end up being more work because if we multiply the denominators, we would have to FOIL them, right? And then go through, and then we have to go back and factor it all back out.
So no.
So it would be more work if we multiplied it first and then factored. So in this case, we want to factor first because it'll make the multiplication simpler. Does that make sense? Alright, so cash. How do we factor the first denominator? What's our DCF? X. Alright, so we factor the x out. What are we left with in the parentheses? And? Very good. So x plus 1. Remember, we factor an x out of the x here. This leaves us with a 1. We can't just leave it not there, right? Now let's look at our second fraction.
Yes.
Carter, how do we factor the numerator?
Take 4 out.
Okay, we can take the 4 out. Is there anything else we can take out? X, very good. So we take the 4x out. What will we have left in the parentheses? X plus 1, very good. Now, we have 2x minus 3 in the denominator. Is that completely factored? Then
Oh yes, the answer is 2x.
yeah, so 2x minus 3 is completely factored, so we can just bring it down here. Now we get the fun of canceling everything out that we can, right? Yeah. So we have a 2x minus 3 up here and 1 in the denominator, right?
Oh, snap.
Wanna know something? What did I just do?
Cross
Was it cross multiplication though?
Cross
X.
Cross simplify. Very good, Annabelle. So if we notice here, we said that multiplying, you multiply across the top and then you multiply across the bottom. So if we wanted to, we could rewrite this as all of this is one numerator and all of this is one denominator. But to save time and work on that, I'm just going to leave it here and we can cross out diagonally. You see that? So on the other ones, we're crossing out up and down. Here we can do diagonally as well when we're multiplying. Does that make sense? Yeah? Okay. How many x plus 1s do we have here?
3.
I heard 3.
3. My bad, my bad.
Yeah. So how many are we going to cross out though?
2.
2.
Why do you say 3, Annabelle?
Because you cross multiply and simplify.
Alright, Brayden, did you want to say something?
But you have to have an even number.
What?
You have to have an even number so
Yeah,
you can make
so what we've been doing is if we had 1 up here, we canceled out 1 down here. We have 2 up here and 1 down here. So how many are we canceling? 2, very good. So we'll cross out 1 here and 1 here. And it doesn't matter which one of the numerator you cross out.
Are you sure?
Yes, if you cross this one out, the answer's going to be the exact same, Davis. Okay, is there anything else left in here that we can factor?
Maybe.
Well, everything's factored. Is there anything else we can simplify? Yes, Brandon?
And just make it 4 times x plus 1.
Okay, what happened to we had a 4x on top. What happened to that x?
It went away.
Why did it go away?
Because
There's
there's
an X on the bottom.
Yeah, very good. So there's an x in the denominator down here, and there's also one up in the numerator.
Wait, I thought we couldn't do that because it wasn't the same.
No, it,
The
yeah,
coefficients
that
don't.
happens.
The coefficient here is not mattering. If we have a 4x here, this is the only factor.
So it'd just be like 4x.
And down here we had an
plus
x.
1 over
Yeah.
x. and you can-
So x over x, kind of like on the number 1, we had 2x squared over x and it equaled out to 2x, right? Our coefficients were different, but we were capable of simplifying because they had the same type of term, right?
I just made a star when I pressed it.
Did someone else have a question?
No.
No? Okay, so our final answer here is then 4 times x plus 1. Yes, Brayden.
I want to distribute that.
Very good question, Brayden. So he just, if you couldn't hear me, he asked, why don't we distribute this? This is because, well, it looks nice, yeah. But also with what we're going to start working on doing, we want to have these in factored form. So if you went ahead and distributed this, then they would have a GCF and we'd have to factor that back out. Does that make sense? So we're going to leave this in a multiplied form like this. Does that make sense? Yeah? Alright, we're going to skip number 4.
Why?
I never liked him.
What? Alright, what do we notice about number 5?
Dividing.
It's dividing. Brayden, what did you say earlier about dividing?
Keep change flip.
Keep, change, flip. Very good. So when we divide a fraction, we keep the first one, we change the sign, and then we flip the second one. So this means, when we look at this, on number 5, our first fraction here, we're going to keep it. We're changing our sign in the middle of multiplication, and then we flip our second one. So we can rewrite this as x squared plus 4x plus 4 over x plus 3 times, yes, Annabelle?
Oh, I was gonna answer the question.
Yeah?
So without flipping it, it would be x plus 2 over 1 to make it a fraction, but then you put the 1 on the top.
Very good, Annabelle. So if you notice here, we have x plus 2. Yeah, very good. So we have x plus 2 here, right? We didn't have any denominator, so that meant it was over 1. Since we're flipping this, she says that since we had a 1 down here in the denominator, we now have 1 over x plus 2. Does that make sense? Yeah? Yeah? Okay, so, yes, Jabez says do sum and product on our numerator over here. So when we use sum and product, what's our sum? 4. What's our product? What factors of 4 add to give us 4? 2 and 2. Both of these are positive, so what's our signs? Very good. We have x plus 2 times x plus 2 over x plus 3 times 1 over x plus 2. So, Angel, what can we cancel out here?
X plus 2.
We can cancel out x plus 2, right? And we're only doing one of the ones in the numerator, right? Yeah?
Yeah.
So, is there anything else we can cancel out here? No. What? I hear no. So then, if we have no, then we can multiply across the top and across the bottom, right? So what's our numerator then for our answer? X plus 2, very good. And then our denominator? X plus 3, very good, Gracie. So, can we simplify the x's here?
No.
No, why?
It doesn't have a.
The numbers on
All the same.
Very good. It's because of our constants at the end here. They're different. These would have to be completely identical to cancel out.
Yeah.
So our final answer is then x plus 2, right?
Yeah.
Alright. So, number 6, we have a division. So we said, what about division? Keep, change, flip. So we'll keep this, change this, flip that. So, let's go ahead and factor our first numerator here. So 2x squared minus x minus 3. Brayden, how do we factor that?
2x minus 3x plus 1
So you said 2x what?
minus 3
And x
plus 1.
plus 1. If you notice on that first numerator there, we actually factored that one on the front already. Did anyone notice that? Yeah? So we already have that one. Now we need to factor our first denominator. So, Kason, what's our GCF?
2.
2. So we factored 2 out. Kason, what are we left with in the parentheses?
X squared plus 4.
X squared plus 4. Very good. So we said we had to do keep, change, flip, so we're changing to multiplying, and what do we do with our last fraction? We flip it. So now, let's go ahead and factor our first denominator. So we've got our second denominator here is going to be 2x squared plus x minus 6. So how do we factor that? Sum and product. So Jabez, what's our sum? 1. Product? Positive or negative 12? Negative, right? So what factors of negative 12 give us a positive 1 when we add? Yes, Brayden. So x plus 4, x minus 3. Is that completely factored, or do we have something else to do now? Topher?
What?
We got our sum and product. We have factors now. Are we done here, or is there something we have to do before we can say this is factored?
Well, then you gotta do the bottom one, don't you?
Well, how did we get our product here?
Oh, that too.
The 2, right? We multiply by 2, so what do we have to do here? Yeah, we have to do the swing method and divide by 2. Right? So this leaves us with x plus 2 times x, 2x minus 3, right? So our second denominator is x plus 2 times 2x minus 3. Go ahead and factor 2x to the 4th minus 32 on your own. Write it down and then discuss with the neighbor and we'll talk about it. 2x to the 4th minus 32. Factor this one on your own. Write it down. Discuss with the neighbor and then we'll talk about it. What? Yes.
Very
What is it? Did we learn how to do a difference of
Oh, I didn't even think about that.
yeah. So we have to do the differences, right? So that gives us this. Is this completely factored? No, so we have to factor more, right?
Yeah.
No.
Let's go back.
Alright, so did everyone get it? Yeah?
Yes.
Did everyone talk with their neighbors about it? No? Okay, Addie. What is the factors of this? You can factor out a 2, and then it's x squared plus 4, x squared minus 4, and then you can simplify the x squared minus 4 to x minus 2 and x plus 2. Very good. So,
I thought it was.
What?
Whoa.
okay, so
Whoa.
wait, what?
So you can so originally it's 2 parentheses x to the 4th minus 16, and then you can do x to the 4th x squared.
Yeah. So originally when we our GCF here is 2, right? So we factored the 2 out, and we're left with x to the 4th minus 16. We see here that this is a difference of squares, right? So this is the same thing as 2 times x squared plus 4 times x squared minus 4, right? Does everyone see that?
Why do you change it to plus 4? Wait, never mind.
Everyone figured it out?
Why do you have so
Can't
many
you
in
just
the
do
neighborhood?
X
What?
minus
Oh, and then you
We're getting
into that. Oh, okay.
Yeah, but then we see here. What, Brayden?
why isn't it just X minus 2?
What?
X minus 2 and then parentheses to the 4.
Because you
What do
gotta.
you mean?
Oh, you can flip
Would that not work?
Oh, what do
X
you?
minus 2 and then parentheses X plus 4.
So, do you see how we got from here to here?
Yeah, but why would that not work?
Because can x squared plus 4 factor? Can x squared plus 4 factor, Brayden?
No.
Can x squared minus 4 factor? Yeah, right? So that's why this doesn't work, is because we can see x squared minus 4 here is still factors. This is another difference of squares. So when we have that, we then have 2 times x squared plus 4. Then we have to factor x squared minus 4, and when we factor a difference of squares, what are we left with on this one? With our factors.
X
X
plus
plus
or
two.
minus.
Very good, so for x plus 2 times x minus 2.
Let's call it 5.
So does everyone see how we got that numerator now? Yeah?
No.
Alright, so now we have to go through and simplify. So the fun part, right? We have 2x minus 3 here. Can we cancel it out with something?
Yes.
What? There's another one in the denominator, so those cancel. What about x plus 1?
Yes.
No.
No.
No, we only have it here. We don't have another one in the denominator. What about our 2's?
Yes.
Yes, we have 2's that cancel.
Oh, you should.
What about x squared plus 4?
Yes.
Yes, we've got x.
Divide 2 by 2.
Yeah, we have x squared plus 4's. Alright? What about x minus 2?
Yes. No.
No, we don't have one in the denominator. X plus 2?
Yes.
Yes, we have one in the denominator. So for this problem, what are we left with for our answer?
X plus
I meant 1
1
minus 2.
times x minus
Very good. So we'll have x plus 1 times x minus 2. Are we multiplying these back together?
2. No.
No, we're leaving them in that form.
Isn't it over 1? Right, why aren't you?
We don't have to write the over 1 in this case. This is the denominator. Alright. Any questions? No?
Oh, one.
Switch to the answer.
That's the answer.
Yeah, so this is our final answer of this one. Any questions?
Questions are just gonna view it on.
Alright, let's look at number 7. Do we see number 7 here?
Yes.
Yes. What are we doing on number 7?
Too much work.
Too much work, yeah.
You got a point.
Okay. Just wait till you see the answer.
And that's what she said to me. It's gonna be like this.
Yeah, so we notice here that we're dividing so we have our first fraction, we're dividing by our second, multiplying by our third. So we're going to start by writing down our first fraction here. Right? So then we have to do what with our sign here?
Multiply. I meant flip.
Yeah, so we multiply and then we flip our second one. Are we flipping our third one too?
No.
No, right? So that one's going to stay the same. We only flip the second one. So we're going to then have x squared minus 4 on top and x cubed plus 1 on the bottom. Then we have our final fraction over here. Right? So here's how we're going to do this.
You have to do this one.
Yes. So this column, I want you to work together to factor out 2x squared plus 5 plus 3. Okay? So you're going to factor that one out. This column, please work together to factor out the denominator of that one. So 2x squared plus 7x
Aggie, what's the
plus
answer?
6. This column,
Let's go. We got an easy one.
x cubed plus 1. It's not as hard as you think.
Just one.
Isn't it just x cubed plus 1?
No, you gotta put 1.
This column, I want you to factor out together x squared minus 4. This one, I will give you x squared plus, minus x plus 1 to factor. And then that leaves this one with
So add a line.
2x minus 4. So work together for a few minutes.
Wait, this is one.
Yeah.
Oh wait, guys.
Let's
I think I know.
It's
It's one.
What's our say about
Get
this?
2 and then C6.
It's one. It's like that.
High five.
So wait, 2
I don't know.
x.
It's like that.
2.
That's how it is.
3 and 4.
I think,
minus 4 equals 12. Divided by 2.
Yeah.
Yeah.
We did.
Good compare.
2x minus 3.
No.
Plus
factored their?
What?
Yes.
Has everyone factored their polynomial?
Yes.
Yes.
No.
Yes.
All right. I need one person from this first group to walk me through factoring 2x squared plus 5x plus 3. Jason.
Alright, so you multiply the 2 times 3, your sum is 5, your product is 6, so it's 2, x plus 2 and x plus 3, and then you gotta divide it by the 2, so it's x plus 1 and 2x plus 3.
Very good. So our first one we will have x plus 1 and then 2x plus 3. Did everyone hear how he did that? Yes? Okay. This group, who would like to explain factoring that denominator?
I guess I'll do it.
Okay.
So you multiply the 2 and the 6, which is 12. So then the sum is 7 and the product is 12. So it's 3 and 4. And then you divide both of those by 2, so it'd be x plus 1 and then 2x plus 3.
Wait.
What did I do?
X plus 2. Okay.
Oh, sorry. Yeah.
So x plus 2 and then you said x plus 3? Alright. So this group, who wants to explain x cubed plus 1 factoring? Brayden?
I did every single one but that one.
I told you to do this one though.
I don't know how.
McKenna, did you do it?
Yeah.
What'd you get?
I got x plus 1 plus x squared plus x.
He said x plus 1 parenthesis.
X squared plus x plus 1. Isn't it?
Hold on. Let me work on my parentheses here.
Wait.
So x plus 1, yes, because we had to take the cube root of both of these. So x plus 1. Yes. I'm struggling with writing right now. And then we should have, so using SOAP, we got the first sign, we need the opposite of a plus is what? Minus, so minus x, and then we square the 1, which would be plus 1, right? So everyone agree on that?
Yes.
Alright, this group, how do we do this? X squared minus 4.
It's just x plus 2 and x minus 2.
Very good. Alright, I believe this group I gave x squared minus x plus 1. Okay, so they say they don't know and they don't have any idea. Brayden, why is this?
Why don't they know?
Yeah, very
I
well.
don't know.
Okay. Let me give you a hint. Look at this denominator, what do you see? And look at this numerator, and what do you see?
No, I know the answer.
Yeah, so this can't factor, right? We already said that when we do the sum or difference of cubes that we can't factor the trinomial and binomial. The trinomial here is the same as here. We know that if we do sum or product, we can't factor it. So we're going to be left with x squared minus x plus 1 here, right?
Yes.
And then lastly, this group, how do we do that? It's like last denominator.
Take the 2 out,
Greatest common factor.
and then it's x minus
Very good. So greatest common factor is 2, and we're left with x minus 2.
2.
Now we get the fun of canceling, right?
Yay.
So let's cancel.
Yay.
What can we cancel?
X plus 1.
So x plus 1's cancel.
Yeah. 2x plus 3.
2x plus 3 cancels.
Yeah. X plus 2.
X plus 2's.
X minus 2.
X squared minus
It's just the
X squared minus x plus 1.
Yep. So, yeah, so, Jolyn is right. We have only the 2 left over in the denominator. Yes, Brayden?
The answer is 1 half.
Yes, the answer is 1/2. Because why don't we have anything else in the
That's the
numerator?
one on the top.
Because it's just 1 on top. Everything else cancels, so we're left with 1 on top. And we've got the 2 left down here, so we're left with 1/2.
Hold it.
Oh, did we do that?
Easy money.
Is it great?
Yeah.
Or just for 1/2? Yeah? Okay. So, when we simplify fractions, what is the first thing we have to do? Factor, right? Factor, what are we factoring, Annabelle?
The binomial.
We missed
Yeah,
number
so the, what?
Are we not going back to number 4?
No, we're not going back to number 4.
Oh,
Why would you
I
say
said we were
that?
skipping it.
Yeah, we do that fairly often. We always go back.
Yeah, Fridays are easy.
Okay, wait. Thank you, Terry. Okay, so we factor the numerator, factor the denominator. When we're multiplying, when we after we factor the numerator and denominators, we simplify top and bottom. How else can we simplify when we're multiplying and dividing?
I meant great common factor. Diagram.
So we have top and bottom that we can simplify. How else can we simplify?
You just cross it.
So we have up and down. What other direction can we simplify?
Diagonal.
Diagonally, thank you.
Straight.
When we divide, how do we divide?
Divide.
Keep, change, split. Very good, Ethan. So your homework will be due on Monday. Yes, Monday.
Yesterday's test.
I don't even know. It wasn't that. It's being on test.
That is a bad thing.
Yes.
We have 2 minutes, so we can wait.
Where did you get that? It's on the square. I was terrified. I mean, it sounded scary. Yeah. I did the machine.
How many words do you need?
What did you use? You used 1700? Sorry. You went over?
No, you can't go over. It was 1750. I don't know. I went back, I was at 1748, and then I went back and I forgot to put in the word two in our essay that we started.
Oh my god.
And I forgot to put in the word two, T-O. I said like something, skip the two and then wrote the next letter, so I went back to this word. So I went back, typed that in, and it was that.
Oh my god.
My dumbness?
Just put this on I know cut
No, since we were writing on iPads, I wanted like autocorrect.
I know. Oh, like so many people have been the best stuff. Like,
Hey, just a reminder, these assignments are due Monday. You're having a quiz. So
Yeah, guys, it's
if you didn't know that.
That's a joke.
I think I'm gonna be sick on that day.
Everybody, she was kidding.
So when is the homework due? Monday. Very good.
I did that.
Have a good weekend. Bye.